Last time we built dungeons, procedurally generated levels full of rooms and corridors to explore. But a dungeon with no monsters in it is just a maze, so before any of that can feel alive, there's some groundwork to lay. And that's what this video is about, getting monsters to actually navigate the world, make basic decisions and react to the player. When working on pathfinding for monsters, the first instinct is to just point them at the player and move them forward. While it works okay in open space, the moment there is an obstacle between the player and the monster would just walk into the obstacle until the end of time. Luckily, Godot has a great solution for that, which is the navigation system. Here's how it works. Godot's 2D navigation is built around something called a navigation region 2D. You give it a polygon, which is an area of your choice. It looks at all the physics geometry inside it and bakes a walkable mesh, the area where monsters are allowed to move through. Baking means creating that fixed navigable area. Each monster has a collision shape, which is a simplified outline of its body that the physics engine uses to determine how it interacts with the world around it. The same geometry can be used on obstacles to punch holes inside the navigation mesh so that monsters avoid certain regions like walls, trees, machines, holes, or anything they shouldn't pass through. The world in industrial dungeons isn't static. Placing down a machine could block a path, in which case the navigation mesh has to be rebaked. Each time a node is added, the mesh reacts to it, either punching a hole or stitching itself back up. That's not the default behavior, by the way. The tree is programmed to react to those updates. My first attempt was to bake the entire map. This can work, but it's very slow. The larger the area, the more work the computer has to do to calculate walkable areas and paths for monsters. So instead, the baked region is a rectangle centered on the player, roughly 400 units in every direction. Only what's near you gets baked. Monsters outside that window don't have a valid path, but that's fine. If they are that far away, they won't be chasing you anyway. When the player is near the boundary of the world, the rectangle gets clamped. It simply ends at the edge rather than extending into empty space. And the region doesn't stay static as you move. Once you have walked about a third of the way towards the edge of the currently baked area, it recenters and triggers a fresh bake. Far enough that you never outrun it, and close enough that monsters near the edges always have a valid path. There's actually a chunking approach built into Godot that splits the world into independent sections that can each update on their own, which might have been a cleaner solution for this. I discovered it a bit too late, but the current setup works well enough that it's not worth ripping out for now. Baking happens in the background and it doesn't happen instantly. And if you place down obstacles fast enough, you can trigger a second rebake before the first one finishes. That bug came up pretty quickly. The navigation mesh would come back corrupted or just wrong, and monsters would behave erratically. The fix was a simple flag. If a bake is already running when a new one gets requested, just remember that and do nothing. When the current bake finishes, it checks the flag. If it's set, it immediately kicks off another one. That way, the mesh is always going to stay up to date with the latest change. Each monster is a character body 2D, with a collision shape and a navigation agent 2D for pathfinding. The agent has options like target desired distance, which determines how close the monster tries to get to the player, and path desired distance, which determines when it considers the path finished and stops moving. There is also a wander timer, a health bar, and a hitbox area for receiving damage. Optionally, monsters can have melee attack or ranged attack, which determine their attacking behavior. The combat system will be covered in a separate video. There are three parameters on the navigation polygon that aren't immediately obvious. Parsed geometry type is what the baker considers an obstacle. Get it wrong and monsters just try to walk through walls. In this case, only static colliders like trees are taken into account. Parsed collision mask is which physics layers count as obstacles during the bake. Walls are considered, other monsters are not. If monsters treated each other as solid objects, they would constantly reroute around each other and never actually reach you. In this game, monsters will avoid trying to walk through full obstacles like trees, machines, and water. Agent radius is the one that most visibly affects gameplay. It's the clearance the mesh leaves around every obstacle. Too large and monsters can't fit through gaps they should be able to navigate. Too small and they clip the edges of walls on corners and stutter. Most of the tuning here came down to adjusting that one value and watching how the mesh changed. The debug overlays like visible navigation mesh and collision shapes are pretty much the only practical way to diagnose what's going wrong here. It's hard to reason about navigation from tutorials alone. Pathfinding every frame would be expensive, so monsters recalculate their path on a 1-second timer. Within chase range, they update to the player's current position. Outside it, they wander or stand around. There's a small delay between the player moving and them reacting, which actually feels more natural than instant response. The stopping distance is dynamic based on the monster type. Melee monsters close in to strike at short range. Ranged monsters were more interesting to figure out. The first version just had them stop at a fixed range. They would shoot fine, but if you ducked behind a wall, they would just stand there doing nothing. Adding a line of sight check changed that. If they can see you, they hold their distance. If something is blocking them, they move closer because they need to re-establish the shot. That one change made them feel dramatically more purposeful. They are not just chasing you, they are trying to get a shot. And that is navigation and basic AI. Monsters that can find their way through a procedurally generated level, respond to the space, and make simple decisions about how to engage. In the next video we will either look at combat or lighting. Thanks for watching.